In this video, we do another example of finding arc length of a function. So we're considering the curve x squared equals y minus 4 cubed, and we want to go from the point 1, 5 to the point 8, 8. So in this one, I've done the problem both as a function of x and as a function of y. So if we do this as a function of y first, which is on the left-hand side, I take the square root of both sides. We get x equals y minus 4 raised to the 3/2 power. It's the positive root because my x's are ranging from 1 to 8. The derivative here will be 3/2 times y minus 4 to the 1/2. Plug that into our arc length formula. We go from 5 to 8. We have square root of 1 plus the quantity 3/2 times y minus 4 to the 1/2, all squared. Simplify under the radical. You'll have a 9/4 y minus 8 under that radical. We can do that with a simple u substitution. Your constant out in front will be an 8 over 27. That comes from 2/3 u to the 3/2, and then we have to adjust with a 4/9. 2/3 times 4/9 is 8 over 27, so that's where that 8 over 27 is coming from. Finally, you plug in your endpoints and simplify, and you should get a final answer of 80 root 10 minus 13 root 13 all over 27. If instead we wanted to do this as a function of x, we would need to solve for y. We would have to take the cube root of both sides and then add 4. So our y becomes 4 plus x to the 2/3. The derivative there is 2/3 x to the negative 1/3. Plug that into our arc length formula and simplify a little bit. We get 1 plus 4/9 x to the negative 2/3 under that radical. Notice in this case our limits are from 1 to 8 because we're doing limits for x, as opposed to in the previous one our limits were 5 to 8. Those were y values. Okay, so to be able to figure out what this antiderivative is, we need to do a little bit more algebra, so we'll get a common denominator. So under the radical, after getting a common denominator, we'll have 9x to the 2/3 plus 4 over 9x to the 2/3. I'm going to pull out that 9x to the 2/3. I'm going to break up the radical on top and on bottom. Square root of 9 is 3, so I'm going to pull that 1/3 all the way out in front. Square root of x to the 2/3 is x to the 1/3. So I'm going to put it off by here by itself. And on the right here, you can see where I've done the u substitution. I let u equal what's under the radical. Du then is going to be 6x to the negative 1/3 dx. So I'll need to adjust with an extra 1/6, but now I have what I have here for my antiderivative is u to the 1/2 du, a value, and then a 1/18 out in front for the 1/3 that I already had, and the 1/6 that we need to adjust for. Antiderivative for that's going to be 2/3 u to the 3/2, so that's why we get a 1/27 here. Our limits change because I have my integral now in terms of u, so if I plug in 1 for x, I get 13 for u. If I plug in 8 for x, we get 40 for u. So that's where the 40 and the 13 are coming from. Now I can just plug in the 40 and the 13 in for u and get the exact same answer as what we got before.